On to topic 1.3, operations on real numbers and order of operations. So here we'll be looking at some of the basic rules for subtracting and adding real numbers, multiplying and dividing real numbers, evaluating expressions containing exponents, find roots of numbers, use the order of operation, and then evaluate algebraic expressions. Some basic strategies of arithmetic and into algebra. They start us off with a football example in which a team loses 5 yards, then loses another 7 yards. How much did they lose altogether? Well, you add these, but since they're a loss, they're both negative numbers. So there's a little bit of a rule. If the signs of what you're adding are the same, we just add them up and use that sign. And that's what they're saying. If they're different signs, as we look down here, in this scenario, let's say one is negative and the other is positive, well, they're suggesting you take the absolute value of the negative 4, which is 4, the absolute value of 3, which is 3, subtract the smaller from the larger, which is 1, but then use the sign of the larger absolute value, which is negative. So there's where you get your negative 1. Now, many of you will use your calculator. You put in a negative 4 plus 3 gives you a negative 1. So here are some examples now. Here they are both negative, so we'll add them together, 14, and use the negative sign. Here, one is negative, one is positive. This is the larger absolute value, which is negative. So you subtract 3 from there, get a 4, and then apply the sign of the larger absolute value. Here, this is larger than this in its absolute form, and it's, in a sense, a traditional subtraction. So 15 minus 10 is 5, and we're going to use the sign of the larger absolute value, which is positive. And when they are decimal fractions, again, you want to be sure to line up your decimals when you do the addition. They're both negative, so we just add them together and the answer will be negative. This will be a 2, and we carry 1, and that is a 10. And again, all these are down here. Now, when we do fractions, and you need to be familiar with fractions, there is a protocol for it, so let me set that up for you. Now, when we are adding fractions, we must have a common denominator, because this one is not equal to this one. But we are allowed to multiply any fraction or anything by 1 that doesn't change the value of the number. So let's first pick out a common denominator between these two. Well, it would be 4. So we can just move this fraction into this part where it'll be a negative 1. Now, there's a plus between them. We want to make 1/2 an equivalent fraction to have a denominator of 4. And we are allowed to multiply it by a 1. Now the form of 1 that I'm going to use will make this denominator a 4. So think about it for a moment, and it would be 2 over 2, which is a form of 1. But now this becomes a 4, and my numerator becomes a 2. So I now have a negative 1 and a positive 2. I can mentally do that. I get a positive 1 over 4, and that's my answer. And that's how they're showing it to you in the solution. Now for this one over here, I've written it out. We're going to find what is my common denominator between a 3 and a 7. Well, often if you just multiply them together, you're going to get 21, which is a common denominator to both of these. I'm allowed to multiply this by a 1, but in what form, so that I get a 21 from my denominator? And if you said 7 over 7, that is correct. And this one, to make it a 21, what form of 1? A 3 over 3. So now 3 times 7 is 21. Negative 2 times 7 is a negative 14. Plus 7 times 3 is 21. 3 times 3 is 9. So now, again, we're going to subtract the smaller from the larger and get 5. And we're going to use the sign of the larger absolute value, which is a negative 21. Now, they usually put the sign by the division bar here, the fraction bar. That's the best place for it. This is correct as well, but when you put it into MATLAB, put the sign there. Now, I thought we'd do the fractions down below just to get some extra practice. Our common denominator, 15. Our form of 1, 3 over 3. Here, 5 over 5. So our denominators become 15. Here our numerator is negative 9. Here a 10. And when we do the addition, or in this case subtraction, in the numerator, we get a 1/15. Now here, when we do this one, our common denominator is actually 22. Our form of 1 here, 2 over 2. So this will be a negative 10. This one is already 22, so plus 2. So we now get a negative 8 over 22. Now, again, we're subtracting the smaller from the larger absolute value, and then using the sign of the larger absolute value. Now, if you put this in the MATLAB, they count it wrong, because you can simplify this a little bit. A 2 can go into there 4 times, and a 2 goes into there 11 times. So we're simplifying that a little bit. So our final answer then is 4/11. Now, when we look at subtracting real numbers, remember it's very similar to working with unlike signed numbers. We can always convert a subtraction that we see here to a form of addition. So we're going to say A minus B, that's subtraction, to A plus a negative B, that's addition. So something to keep in mind. So when we do examples here, they're not asking us particularly to, convert it to addition, but we can. This would be the traditional subtraction in a sense. Knowing our rules, the larger absolute value then would be 8, which is negative, and our 2, which is positive, which will give us a 6, subtracting the smaller from the larger, and then using the sign of the larger absolute value. And here, recall from a previous lesson, the opposite of a negative makes this a positive. So now we have a negative 8 and a positive 1. That'll give us a negative 7. Here we have two negatives. We're just going to add them together and use the common sign, negative. And again, this becomes a positive. And you want to line up your decimals. So the opposite of a negative is a positive. Two negatives make a positive, and we can just add them up. In example E, we have fractions that I've changed to an addition form. And again, our common denominator will be a 6. The form of 1 that will multiply each fraction to end up with a common denominator of 6. Here it will be 2 over 2. Here it will be 3 over 3. So our denominators become a 6. This is a negative 4 plus a negative 3 gives you, since they're the same signs, a negative 7 over 6. Now in this form, it's what we call an improper fraction when the numerator is larger than our denominator. So we can convert that, if we'd like, to a mixed number. 6 goes into 7 once. There's 1 left over. And the whole thing is negative. Okay. Now notice they are leaving it in its improper fraction form. This is another acceptable answer as a mixed number. If you have a mixed number, the routine to get it to be this is multiply your denominator by the whole number and then add the numerator to it. That's what we have there. And again, setting up example F, you can't really subtract 6 from 0, but if you borrow, this will become a 10. This is then a 9. So this then becomes a 4. This is now a 9. And we borrowed in a sense. All right, there you go. Now, this next one is critical because of the language it's using. It's saying subtract 7. So we could write it, subtract 7 from 4. This is what they have in words, in a sense, that they want you to use that negative sign there. You must convert this sign to a negative to get the answer. And that's one way of looking at it. Now you might write it this way. 4 subtract 7. Another way. Either way, you get the same answer. The smaller absolute value from the larger is 3, and you apply the larger absolute value sign, which would be negative. Okay. In example 3, the strategy might be group your like terms together. This gives you a 13 minus 7. And then now it's just simple subtraction. And this will give you a 6. Again, group your like signed items. This gives you a -9 plus 2. So subtract the smaller from the larger, get a 7. Use the sign of the larger absolute value. As we go into multiplying and dividing real numbers, remember multiplication is a shortcut of addition. 3 times 2, so we have 3 2's, add up to 6. We know 3 times 2 is 6. 3 times a -2, you're adding 3 -2's, you get a -6. Now, there's some rules that we need to look at here, and we'll just review them up here. Now, if you multiply a positive times a positive, the sign is going to be a positive. If you multiply a negative by a negative, the sign will be a positive. So from this we can pick up, if we multiply like signs, the results are positive. Now if you multiply unlike signs, one is positive, one is negative, then the results are always negative. So whether it's negative times positive or positive times negative, unlike signs, not like, but unlike signs, the results are negative. And that's what they're saying here. And a quick review of the product property of 0, that anytime 0 is one of the factors, the results is 0. So let's work on these. Now I always suggest to figure out what sign will you have. Well, like signs, it'll be positive. 8 times 1 is 8. What sign will you have? Well, it's going to be negative. And here, notice that there is a common factor here of 2. So we can do some canceling. Remember, this is 2 over 1. So 2 will go into 2 once. 2 will go into 6 3 times. And they're unlike signs, so we know our answer will be negative. And now 1 times 1 is 1. 1 times 3 is 3. So a negative 1/3. Now for something like this, 1.2 times now 0.3, and our value here is negative, so our answer will be negative. And we go 3 times 2 is 6. 3 times -1, in a sense, this whole thing is going to be negative, is going to be 3. And we know it's negative. And then we say, we count the number of decimal places we have. Well, there's 2 decimal places in our factors, so we have to have 2 decimal places in our answer. And that's how they get this. Again, putting that into your calculator, you get the answer right away. Now in letter D, anything times 0 is 0. And then here we say, can we do some cross-canceling? And the answer is yes. So let's just write it out. 1/5 times a -10 over 11. Well, we know our answer is going to be negative because they're unlike signs, but we see the 5 will go into there once, 5 will go into the 10 twice, so we get a -2/11. Now, the way they're showing here, they're multiplying the numerator, multiplying the denominator, and then simplifying. I strongly advise if you simplify ahead of time, it's much easier than figuring out what you have to do there. Now, when you're going to multiply 3 or 4 factors, you can take it in parts. You can multiply this and get a positive 6. Now, 1 times 7 is 7. So this becomes a 42. So whenever you have a string of factors, that would be a technique. Now, in looking at this, 0 is a factor, so this is just going to be 0. Now, a helpful hint as we go along here would be if you have an odd number of negative factors, like 3, 5, 7, odd numbers of negative factors, the product will be negative. If you have an even number of negative factors, 2, 4, 6, the results will be positive. So again, figure out what your sign will be before you do something. So for instance, this will be negative, positive, negative. This is 0, negative. 2 negative signs, even number. This is going to be positive. This would be negative. Now, when you're dividing, that is, you have a fraction, let's say, and the numerator is one sign, the denominator is the same sign, you have like signs, both negative or both positive, the results will be positive. It's the same rule. If it's one's negative and the other is positive, unlike signs, the results is negative. Okay? Now, they are introducing a term here that I want to have included in your vocabulary, that is reciprocal. Well, if we have 1 over 5, by multiplying something by its reciprocal, the result is always a positive 1. So what do we have to multiply 1/5 by to make it a 1? And we said it's going to be its reciprocal. Well, what is the reciprocal? Well, you may remember it's just flipping the number over. Put the denominator in the numerator and vice versa. So what happens here now is the 5s can cross cancel, and everything is 1 times 1 times 1 times 1 is 1. Now it's a positive 1. So if you had, let's say, a negative 2/5, its reciprocal, so that you would get a positive 1, would be the same sign, because it has to be like signs to make something positive, and then flip it again. 5/2. So again, everything would cancel out and you end up with a positive 1. Now, they're also mentioning one of our basic rules, that if you have 0 divided by any number that's not 0, this always is a 0. But if you have a number like 5 divided by 0, in our mathematical system this is not defined. So 0 divided by any non-zero number is 0. But 5 divided by 0, this is undefined. And they explain this in our text here. So some of these are straightforward. What will our sign be here? Well, it's going to be a negative, and 4 goes into 20 5 times. Now here our signs are the same, so our results are positive. 3 goes into 9 3 times. Now, when we have something like this, we can look at this as a division of fractions in a sense. We could put that 3 over 1, write it this way. Now, when we are dividing fractions like this, there is a little strategy of doing them. We write out our first item, but now we change our division to multiplication, changing that from division to multiplication, and now we take the reciprocal of what we have here, which will be 1 over 3, and then we multiply. So here we can cancel, cross cancel, these become 1s, so we have a negative 1/8, which is what they have right there. Now here, our division, unlike signs, so our answer will be negative. 10 goes into 40 4 times. And here we have another division of fractions, but this one's negative, so our answer will be positive. So we go 1/10, change our division to multiplication, and take the reciprocal of this, which will be 5 over 2. Here the 5's will cross cancel, and we get 1/4. Now remember, we can actually, since we've dealt with the signs already, we know this is 1/4. So figuring out what our signs would be ahead saves us having to deal with them here. And then anything divided by 0 is undefined. Oh, my pen's not working too well. There we go. Another little thing they're showing us here is that where can we put the negative sign? Well, here it's in the numerator, and it's a negative 4. Here it's in the denominator, and it's a negative 4 when you simplify. Here it's by the division bar, the fraction bar, and it's negative 4. So all of these, in a sense, are equivalent, and by convention, the most common place to put that negative sign, as I mentioned earlier, is by that division bar. And they summarize it in our textbook by saying this. But again, our denominator cannot be 0. That's why they're giving this qualifier. B cannot be 0, our denominator. And the best place, or the convention, by convention, they put it by the division bar. Some vocabulary words. Evaluating expressions containing exponents. Well, the 3 times 5, these are factors. When you multiply factors, you get a product. Now, a shortcut in mathematics is when you have factors that are all the same, as we see here, we can write that in shorthand by putting a super number here, or upper value, super case there, 4 to the 3rd power. The 3 is the exponent, and the 4 is the base, the number of times that factor is multiplied by itself. And then, of course, simplified is 64. So it gives us then a definition. A is our base, n is our exponent, and it's to that many times that you multiply your base. So we'll do a little practice. Now, when you see the number 3, you might say, well, it doesn't have an exponent. Well, they do. For instance, every number has an exponent. Every variable has an exponent of 1. We just don't write it. If it's not 1, then we write it. So 3 to the second is 3 times 3 is 9. Now this, as we see down here, indicates 1/2 that is written 4 times. So this becomes 1 to the 1/16th. The exponent applies to the numerator and denominator. Now this one is tricky, because what is our base here? Is it -5 or just the 5? And the answer is just the 5. So here we raise 5 to the second power, which is 25, and we now apply the negative sign. Very critical, this. And they're showing that here. Now, in letter D, we have in parentheses -5 to the second power. How does that differ? Well, now, because of the parentheses, the base is -5. -5 times -5 gives you a positive 25. And again, if we use the base to an even power, 2, 4, 6, the answer will always be positive. If the base is raised to an odd number of powers, 3, 5, 7, then your answer will always be negative. We had that rule a little earlier. Okay, now for this one, again, it's a -5 to the third. Our base is just the 5. So 5 to the third is 125. Then you apply the negative. Now here, because it's an odd number that we're raising a negative to, again, it's going to be a negative value, 125. So the answer for this one and this one are the same. But keep in mind, if this were an even number here, that would have been negative, regardless of how many times. Because of the negative out here is applied after you raise it to that power. Here, depending upon what the exponent is, if it's odd, you're going to get negative. If it's even, you're going to get positive. Okay. And a concept check, they have these every once in a while. The exponent is odd, so what will be the sign of the answer? Odd, without making the calculation, because the exponent is an odd value. Okay, some helpful hints that I believe we've covered, and let's move on. So objective 4 now is finding roots of a number. Well, when we have a number like 2, and we're raising it to the power of 2, we get 4. Now 4 is a perfect square. We also have, earlier we mentioned the radical sign, which is square root. So when we're asked to finding roots of a number, we're asked, let's say, to find the square root of 4. Well, that is, what numbers, what factors time themselves give you a 4? Well, it's 2. So the square root of 4 is 2. Now, this is the positive or principal square root, because this could possibly have another value. If you were squaring a negative 2, that would also be a 4. So keep in mind that normally we look for the positive or principal square root, but there could also be, this could be a negative. How would you know? Well, often we don't. So if we want to ensure that we're dealing with this, we would put a negative sign in front of the radical sign, and that would always give us our negative value. And they're describing that here. Now keep in mind that if under the radical sign you have a negative 4, that's not going to give you a negative 2. Because if you square a negative 2, you get a 4. There's no way to square two numbers, that is, use the same sign and get a negative. So we describe any time we're going to have under the radical sign a negative value, that this is not a real number. So we're looking for the principal or positive square root. Square root of 9, 3. 25, 5. 1/4, 1/2. Now again, square root of 36 is 6. Then we apply the negative. Now with the negative under the radical sign, this is not a real number. Now when we have the radical sign, there's a little notch over here. What we put here is what is called the index number. If there's no number here, then there's actually the 2, where we're taking square root. Now for all the others, we can have the third root of something, or the fourth root of something. This index number tells us the type of root we're looking for. So for instance, if we had here, they're saying a -8. Well, now notice it's an odd number for our index number, so having a negative there is okay. It's just if the index number is even, we can't have a negative underneath there. Those are not real numbers. But for odd index numbers, you can have a negative. Now, if you took this, and they're showing you here that the cube root, or the third root of -8, is -2. If you took -2 and cubed it, you would get a -8. So that's what they're looking for. So here they're saying the cube root of -27 happens to be a -3. Now the fifth root of 1, this is an easy one, the fifth root or any root of 1 is 1. And the fourth root of 16, and you may have to play around with this, is 2, because 2 to the fourth is 16. And they show you these here. Now the third root of 64 is 4. The fifth root of a -1 is a -1. And the fourth root of 10,000 is 10, because 10 to the fourth is 10,000. Now there's a way to do this on your calculator that if you ask me, I'll tell you how to do it. They're mentioning that in some of these roots, since they're all perfect cubes or squares or to the fourths. There are, of course, the irrational numbers, but we don't treat that in this class. Going in now to using the order of operations, you might recall this statement, "Please excuse my dear Aunt Sally." It's a way that when we are asked to compute something, we kind of group this in groups of two here. This is parentheses or grouping symbols and exponents. From left to right, we do that first. Then from left to right, multiply, divide, and then add, subtract last, from left to right, whichever comes first. And this is what they're saying. And they're also showing you some grouping symbols: the fraction bar, the radical sign, absolute value bar. Now, just the division bar here, that's not grouping because there's just one item on top, one item on the bottom. Just a single item under the radical sign, it says to do this, and this is a single thing. So it's when there are various items, these can also act as grouping symbols. So let's go on to do some examples. And why grouping symbols? You want to get what is there so that everyone gets the same answer. So what do we do first here? Do we multiply or divide? Well, what's on the left is division. So we're going to do the division first. So we divide by 2, get 10. Then multiply by 10 and get 100. Now here we're going to do what's inside the grouping symbol and get a -3 that we're going to square. That's going to give us a +9. So now we do the multiplication, which is 18 plus 1 is 19. And here, this comes out of the absolute sign as a 2. 2 to the third power is 8 plus 1. That's going to be a 9 on top. This comes out of the radical sign as a +2, but we take the opposite sign, so -2. -7 is a -9, which equals a -1. And we'll see that down below. There we go. Now they do get a tad challenging, but we can follow the model right there. So what we would do here is do what's in this parenthesis. So this is going to be a -2 here. This is going to be a -4. And they have that here. So this is a -8, -2, -10. And then there's a negative sign in front. So we take the opposite sign. 2 negatives will make this a positive. And 3 plus 10 gives you 13. Now for this one, again, it's using the grouping symbol. This gives you a 25. We're going to follow all of these, and eventually you're going to get a -21 over 19. And the steps are there. We'll pause it, and you can study it. Now, looking at evaluating algebraic expressions, what they will do here is take each of our values. X is 4, y is a -3, and then carefully introduce it through substitution into our expressions, and then carefully simplify. If I did every single one of these, it would take quite a time. Of course, you're going to have your chance as you do your practice and your mastery. Now, sometimes values have what is called a subscript, such as this. X sub 1 is something. X sub 2 is something. And they give you the formula and you just substitute. Now you don't have to worry that they're sub 1s. They're just designation of variables. Now here we're asked to put various values for x. In this first case, a -4, a 10, a 32, and see what you get when you do a series of substitutions. And the book gives you the solutions for each one, how you would do that, and the answers. I see our tape is running a little bit long, so I'm not going to try to extend it too much longer. And then we get into our vocabulary and the end of section exercise. All right.